So for this bit of notes, we're going to be looking at what are basically just fractions. And if you recognize that they're nothing more than fractions, then the process to solve them becomes so much simpler. So we're looking at fractions with like denominators, which means that they have the same number on the bottom, the denominators. And we're going to be adding rational expressions. So the rational expression part is what starts throwing people, and when you mix it in with fractions, then they start going, I'm done. They start throwing in the white flag. But let's look back at our foundations of fractions and how, when we're working with our rational expressions, it's really going to be quite similar. So a basic like denominators that we might be used to, something along the lines of like 2/5 plus 1/5. Boom. Basic. If you remember with fractions, we do not change the denominator at all. It's going to stay fifths. That's our size. It's kind of like if we are working with quarters. If we add 3 quarters together, we don't magically get $5 bills. It would be nice if we did, but we don't. We stay with that size, that unit of measurement. Up here indicates how many we actually have. We had 2 up here, and we had 1 more, and so thus that gives us our 3/5. So this is a traditional fractions with like denominators that would be adding. So when it comes to starting to become rational expressions or variables, this process is not going to change. So if we had 2 over x plus 1 over x, we simply get 3 over x. We don't know what x is, and technically we really don't care. It's a certain quantity, it's a set quantitor, it's the same between both of them, and so it's going to be the same over here. So even if we expand this, and let's say x plus 4, and 1 over x plus 4, this is just going to all come over 1 variables. We're going to have 2 plus 1 over x plus 4, which reduces down to just simplifying of 3 over x plus 4. Do you necessarily have to show this step here? No, but it is going to come in helpful when we start doing larger, more complicated rational expressions. Okay, and these are basically, all these are rational expressions. Rational and fractions are very similar in their term and basically the way they work. It's a fancy word for it. So what if I had something that said 2x over x plus 4 plus 1x over x plus 4? The only thing that's going to start happening is we're getting into more complex versions of combined like terms. So we have to remember that this just means that we're going to take 2x plus 1x and still all over my x plus 4. Combined like terms, they have the same exponent, which is 1. So I combined what's called the coefficient, or my number in front is my coefficient. So I get 3x over x plus 4. But what if I start adding something that looks like this? 2x plus 3 over x plus 4 plus 1x plus 5 over x plus 4. The neat concept is it's just a complex version of what's up here. I have a numerator, I have a denominator, I have a numerator, I have a like denominator. So my denominator is not going to change. And the only thing I'm going to do is combine or add my numerators. So I'm going to have 2x plus 3, which is going to be added to 1x plus 5. So here I get into a little bit more advanced combined like terms. I have my 2x and my 1x, which is going to give me 3x. I have 3 plus 5, which is going to give me 8. And it's going to go all over my x plus 4. And I'm finished. I can't simplify my numerator. There's not a number that I can do reverse distribution and distributive property here. And I can't cancel anything out. So I am finished. And we'll be able to get into more canceling later, but initially just looking at the basic process of adding. And I can make these as complicated as I want on my numerators, but as long as my denominator is the same, I'm just going to combine like terms up top, keep my denominator the same, reduce if possible, and I'm done. So I hope that helped.